welcome back. We have today 1268 search suggestion system. It says here you're given an array of strings products and a string search word. We are to design a system that suggests at most 3 product names from products after each character of the search word is typed. Suggested products should have common prefix with the search word. And if there are more than 3 products with a common prefix, we are to return the 3 lexicographically minimum products, so the ones that come ahead alphabetically. And we are to return a list of the suggested products after each character of search word is typed. So in this one, we are going to use 2 approaches. First, we use try, and we're going to modify the typical try by also inserting the suggested word while we're building the try. Okay, so let's take our example here, bring it here, and let me write it here. Okay, so we have our products. These are our products, and this is the search word. And our goal is we're gonna search first from the first one, then onwards. And for each character, we want to return the first 3 that are coming up that share the same prefix. Okay, so the way we're gonna try this is, let's say we have the root, which is the beginning of our try. And first thing, we're going to sort this so that when we insert our suggested word, we can simply track how many words or suggestions we've added thus far. And that way, if we're ever at max capacity, then we can ignore. And naturally, as long as this initial list is sorted, whatever we have in our suggested list will already be sorted. Okay, so if we sort this, let's see, command, let's grab this one, and I'm going to use our terminal. Oh, I already have a sorted version, so let's swap this out. Okay, so this is our new version, and let's start with the first word, which is mobile. Mobile, we'll start with the M. So our root currently has no children, so let's add the M. M is going to be our first character over here. M, once we add the first character, let's add to it the suggested word. And just for space, I will add the indices instead. So for M, once we're at M, we have suggested word mobile. Okay, M is done. Next is O. M does not have any children, so let's add the O. And O, we can also add 0th word mobile as our suggested word. We can continue down the line for B, I, L, and E. And for each of these, the suggested word is mobile because we can have up to 3, and these are all currently empty. Okay. All right. Now we're done with the first word. Next, we have money pot. So we're going to do M-O. There is M. There is O. O does not have N, so let's add that. Oh, and also don't forget, we need to add our word. So money pot is at index 1. Let's add that. O as well. They share the same prefix. Let's add that. Once we're at N, its first suggested word is money pot. So let's add that. Okay, and then continue down the line. M-O-N-E-Y-P-O-T. Okay, and then for all of these, the suggested first word is money pot. Okay, so we're done with the second word. The third word is monitor. For monitor, we start at the M, And M currently has 2 suggestions. It has space for a third one. So let's add the third one, which will be monitor. Continue down to O. There's also space. All right, and these 2 are full, by the way. And then N, we can add monitor. And N, after N, there should be an I. So let's add one here. Actually, let's add one here. And this is going to be I-T-O-R. Okay. And for I, the first suggested word will be monitor. And for all the subsequent characters as well. All right, we're down 3 words. Our next word is mouse, M. Now, it does share the prefix, mouse, M, does share the prefix. However, our suggestions bank is full. So we cannot add this guy, but we continue down the line. Next character is O. O is also full. U is not a child. So we can add a U, U-S-E. And this one, we can finally add 3, which is our word mouse over here. All right, and our last word is mouse pad. Mouse pad. M is already full, O is already full, U can take some more. So let's add mouse pad, M-O-U-S. Let's add mouse pad again. Mouse pad again. And this can continue, so mouse and pad. All right, and for these remaining characters, the first suggested word will be mouse pad. Okay, it's getting messy, but we're almost there. Okay. And so if we review, up until M-O, we have 3 suggested words. Down this line, we have 1 each. Over here, these are all the suggested words. Then, once we have this try built in, and we already, while we're building the try, we already have the suggestions built in as well. Once we get the search word, it's quite simple. So when we have M, let's say we have M, we basically just return whatever is suggested at the M level. Let me do a different color. Okay, so M is the first word. We're at M. We just return this. That's it. Okay, next, O. We're at O. We just return that. U, M-O-U. U is over here. U has 2. It said at most 3, so we have 2. M-O-U, and then S. S, we have 2 as well. And E, we have 2 as well. And all we would do is return this in the list. And so that would be, so we would start with M-O-U-S-E, where at M we get 0, 1, 2, or no. Let's say if we do it exactly, it's mobile, money pod, 0, 1, monitor. That's when we have M. Let me move this here. Yeah, so that's at M. And once we are at O, it's 0, 1, 2, they're the same. So let's say same. Oops. And then that's M-O-U. Once we're at U, we will have 3 and 4, which is mouse and mouse pad. Hang in there, almost there. And then for those 3, actually, it's the same. So same. And same. All right, and there we have it. So that's the basic logic. And now we can translate this into code. Okay, so what did we do first? First, we created our try. So let's create a really simple try. We'll handle the counting, all that in our solution code. This one is simply for our node, which will have some children, which will be the characters that it points to. We can initialize that as a dictionary. And then a list of suggestions. And we won't handle it here, but we're going to take at most 3. Okay, and then what else? We have the try. So let's use it. Let's use our try. For every product, so for product in products, okay, and to do that, let's first initialize. So we have our try, which is a try node. For product in products, we are saying we're going to do something for char in product. For char in product, we take the node. Let's have a pointer to the beginning. So cur is going to be the root. Okay, so we start at the top and say for every character in the product or the product name, if the character does not yet exist, if char not in cur nodes children, then let's first add it. Cur.children char is going to equal to a new try node. All right. So once we have that, we handle in case the character doesn't already exist, we add it. Now, once we have that guaranteed to be there and to exist, we can move to it. So cur is now equal to cur.children at that character. Once we move there, we can add to its suggestions our current word, only if it has capacity. So if the length of the cur.suggestions is less than 3, then cur.suggestions.append, and we can add our current word, which is product. Okay, so we have a node, we're iterating each product, we initialize our pointer to the head of the try node, we're iterating each character in product and making sure that character does exist by adding it if it doesn't already. And we are moving to it, and then we're adding our suggestion if there's capacity. And we're going to do that for every character, and then by the time we exit this, theoretically, we should have this all built out. Okay, so what else follows? Now we have this all built out. Next, we have the search word. So let's say for character in search word, we're going to have some results, which will be the size of the number of characters in our search words. So let's initialize that time, that for, and range length of search word. Okay, and I do want the indexes, so let's use enumerate instead. And this will give us access to the index and the character. Okay. So for each index and character in our search word, all we're doing is setting the result at that character index to whatever is the suggested list of that character. So I think we would need to start at the root. Okay. So let's have a pointer to the root. Okay, and then if char is not in cur.children, then whatever it is, we no longer have a path to our target word. So we can break out of this for loop, and once we break out, we'll return the result down here. Now, if we don't break out, then we have the character in the children, so let's move to it. So cur is going to equal to cur.children at that character, and we can add to our result at that index whatever is cur's suggestions. We can either assign it or we can do extend. So we'll be adding all the values into that position. And once we have this, we should have results. Let's print that up and see what that looks like. Okay, we have mobile, mouse, and money pot. Mobile, oh, I see, mobile, money pot. Mobile. Okay, so we know what happened. If we look at the result here, let's say we run this, then oddly enough, we get, for the first one, for instance, when we search M, instead of getting mobile, money pot, and monitor, like so, so mobile is the first one down here. Let's, add some color, maybe white. So mobile, that's the first one. Next one is monitor, then it's next one is money pod, then it's monitor. So what went wrong here? Well, if we see, the initial input is mobile, mouse, money pod, which is what we're returning. So basically, we forgot to sort. This over here is sorted. However, our input is not. So let's add that at the beginning. So products.sort. And that's it. Let's run it. And let's submit. And there you have it. This is, once again, 126A search suggestion system, where the main idea is we're using a try node where each node points to some children, which can be characters. And what's special about this try node is it also contains suggestions that represents an array of strings where within the solution part, we are handling whether or not it has the capacity to take on more suggestions, then we add it. And the key, as we forgot it, is to sort. Because by sorting, while we're building the try, we'll know that whatever we insert will be already in alphabetical order. Thanks so much. Happy coding. See you next time.